Hello, my dear students. I welcome you to the part number 2, that is Rutherford model of an atom of chapter number 4. Student, in this particular video, we will discuss regarding these 5 important subtopics and what these are. First of all, we will discuss regarding the alpha ray scattering experiment. Alpha ray scattering experiment, students, is actually performed by Ernest Rutherford. We will discuss regarding this experiment. Then, second main important subtopic, students, is the observation of alpha ray scattering experiment. After this, we will also discuss regarding the conclusions of alpha ray scattering experiment. And depending upon this conclusion, there is actually a model given by Rutherford, and that model is known as nuclear model of an atom. So we will discuss regarding that particular nuclear model of an atom also in this particular part. Then fifth subtopic that we are going to discuss in this video is the defects or limitation of nuclear model of an atom. Nuclear model of an atom given by Rutherford is actually not perfect. It is having a lot of limitations and defects. After watching the video, students, you will be able to understand the alpha ray scattering experiment. You will be able to recall the observation of Rutherford model or experiment. You also will be able to list the conclusions made by Rutherford. Along with this, you also will be able to explain the nuclear model of an atom. Last but not the least, you also will be able to understand the limitations of Rutherford model of an atom. Let's move to the next slide. Student, this is the YouTube video link. With the help of this particular YouTube video, you can also understand the Rutherford alpha ray scattering experiment. This video is brought to you by Khan Academy. This particular section that we are discussing here in this particular video, students, this belongs to your NCERT book from page number 47 to 48. Let's move forward. In this slide, students, we will discuss regarding the Rutherford model of an atom. Students, Rutherford model of an atom is not a philosophical model. Likewise, the Thomson has given his model. But this particular model is based upon a very much renowned experiment, that is your alpha ray scattering experiment. So what this experiment is all about, let us discuss this experiment. Students, Rutherford allowed a beam of fast moving alpha particles having a positive charge to fall on a thin gold foil. So let us understand this experiment. Actually, these alpha particles are positively charged, and Rutherford allowed to fall these alpha ray particles on a very thin gold foil, and the thickness of this gold foil, students, is approximately 2.1 into 10 raised to minus 7 meter. And he has placed this thin gold foil in the center of a rotatable detector which is made up of zinc sulfide. You can say it is a screen which is made up of zinc sulfide. So after conducting this experiment, what observations are actually made by Rutherford, that observations are given over here. Let us understand these observations one by one. So first observation made by students Rutherford is that most of the alpha particle passed straight through the gold foil. As you can see here also, these rays are moving straight through the gold foil. As you can see here in the GIF image also, that most of the alpha ray particles or most of the beam are moving straight through the gold foil, and he is obtaining these alpha ray particles or the beam of light on the screen that is made up of zinc sulfide. So this is about the first observation. Then let us discuss the second observation made by the Rutherford. Rutherford has observed that some of the alpha particles were slightly deflected by small angles. As you can see here in the picture, these alpha particles which are moving little bit closer to the nucleus, they are getting deflected by small angle. Why is it so? Because you know very well that the alpha ray particles are positively charged, and it is only possible, or you can say the deflection is only possible when there is something positive inside the center of an atom. So that is why this deflection is occurring there. Then let us understand the third observation made by the Rutherford? Rutherford has observed that very few particles, that is alpha ray particles, appear to rebound. Say 1 out of 10 to 12,000 alpha ray particles or beam is getting rebound or getting bounce back. As you can see here that very few rays are getting bounce back, means they are returning to the path from where they are coming back, and it is
Let
only
us try
possible
to understand
when
this with the
the two
help of an
positive
indoor
charge
game, that is
strike
a
with
carom board.
one
Students,
another.
if you are able to understand or if you are able to recall a scene from the carom board when you are playing it, when you will hit the carom coin with the help of a striker, then if the striker is hitting the central part of the carom coin, then it will bounce back. So similar is the condition that we are talking about here in the case of the alpha particles and the nucleus.
So let's move ahead. Students, after conducting the alpha experiment and after the observations, Rutherford has made certain conclusions regarding the structure of an atom. And what these conclusions are, let us understand. The first conclusion made by Rutherford regarding the structure of the atom is that according to Rutherford, most of the space inside the atom is empty. Why? Because most of the alpha particles are passing straight to the gold foil. As you can see here in the image also, that most of the alpha particles are moving straight. So this is the conclusion made by Rutherford, that this is a possibility, there is a possibility that most of the space inside the atom is empty. That is why these alpha ray particles are moving straight. Then let us discuss the second conclusion made by the Rutherford. What is that? According to Rutherford, the atom had a small nucleus which is having a positive charge. Why? Because some of the alpha particles having positive charge were slightly deflected by small angle, and this we have discussed in the previous slide also, that deflection is possible only when these positively charged alpha ray particles are moving very closer to the positively charged particles. Then let us discuss regarding the third conclusion made by Rutherford. What is that conclusion? According to Rutherford, the size of the nucleus is very small as comparison to the size of the atom. And why is it so? Very few alpha particles appear to rebound, and most of the positive charge and mass of the atom is in the nucleus. So this is how Rutherford has made conclusion regarding the structure of an atom. And after this conclusion, Rutherford has given a very much renowned model that is actually known as nuclear model of an atom. In order to understand the nuclear model of an atom, let us understand these points. According to Rutherford, an atom has a positively charged nucleus at its center, and most of the mass of the atom is in the nucleus, because we know very well the electron mass is negligible as compared to the proton and neutron. Then the second point regarding the nuclear model of an atom is that according to Rutherford, the electrons are revolving around the nucleus in different orbits. If you are able to recall the J.J. Thomson model, this is the contradictory point. Why? Because according to J.J. Thomson, the whole atom is the positively charged sphere and the negatively charged particles are embedded in it. But according to Rutherford nuclear model of an atom, these negatively charged particles are actually revolving in the different orbits. So this is the second point regarding the nuclear model of an atom. Then let us discuss the third important point regarding the nuclear model of an atom. According to Rutherford, the size of the nucleus is very small as compared to the size of the atom. You can see here also the size of this nucleus. If we will try to find out the size of the nucleus, then this is this much, and the size of the atom is this. So according to Rutherford, the size of the nucleus is very small as comparison to the size of the atom. So this is how Rutherford has given the nuclear model of an atom. But this nuclear model of an atom is also not completely right, because other group of scientists start raising certain questions, and what that questions are there, let us understand that. According to other scientists, any charged particle when it is moving in a circular orbit. Likewise, this electron is revolving in this particular circular orbit, then it would undergo acceleration, and during acceleration it is going to radiate energy. What is the meaning of radiate energy? Radiate energy simply means when or while these electrons are actually revolving around the nucleus, they are going to lose the energy and finally they will fall into the nucleus. Why is it so? Because electron is having negative charge and the nucleus is having positive charge. So opposite charges attract each other. If it is going to lose its energy and it is not having the optimum energy to keep rotating in this particular orbit, then finally the electrons are going to fall in the nucleus, and according to this type of the model, the structure of the atom would be unstable. We know very well, but the atom is quite stable. So this becomes the biggest limitation of the Rutherford model of an atom. Later on, these defects are actually corrected by Niels Bohr in his atomic model. We will discuss regarding that model in our part number 3 of chapter number 4. Students, in order to analyze the understanding level, try to give the answers of these questions. These are some practice questions for you. These are 5 questions. After watching the video, you are supposed to give the answers of these questions. If you are able to give the answers of these questions, then you can move ahead. For assignment, you can check the part number 1 of chapter number 4 and try to attempt the questions of the assignment that belongs to this particular part, that is the part number 2, Rutherford model of an atom. And at the end, thank you for watching the video. Stay safe, stay at home, happy learning, and if you like the video, hit the like button, share the video and subscribe the channel too.
Day in, day out, it's the same road we're walking down. Same job, same town, 'cause we've been told that's the way our world goes round. Walking on the grounds we've always known.